This video was created by Gwilhelm Caher from Imperial College London and should not be distributed outside of Imperial College. It is aimed at research students or staff from Imperial College who have never fitted a core level spectrum before or have just fitted the Carbon 1S example. Similarly to the previous example, we will use the Avantage software from Thermo to fit our data. This is a spectrum of a chlorine 2P core level from a sample with a surface made of different organics, chlorine and copper. I have placed a knowledge view on the side to help identifying the different species. The knowledge library is very small for chlorine, and it is best to look at the NIST library. I have also on the side the NIST page for the chlorine 2P3/2, which we will use later for the identification of the different species. Now, before doing any peak fitting, you need to have a good knowledge about spin-orbit splitting and particularly about the S, P, D, and F subshells. Learn about the reason these subshells are split into doublets. So, in the case of the P subshell, it is made of 6 electrons and split into 2 components, namely the 3/2 and the 1/2. The 3/2 has 4 electrons, and the 1/2 has 2 electrons. For this reason, you can observe on this spectrum that the area of the 2p1/2 is half of the area of the 2p3/2. Let's start to peak fit the chlorine 2p core level. First, look at the data. As you can see, there are 3 observable peaks. You can use the ID function as shown on the top left. All the elements which are selectable here are the elements that can be present at these binding energies. We know that we should have chlorine, and from the previously measured survey, we also know that we should have phosphor. The survey spectrum is not shown here. Clicking on the phosphor, we can see that the peak at 192 eV matches the P2S core level. Let us select a range that will not include the P2S peak. This icon is located on the bottom left as shown. Allow for 3 eV of background on each side of the spectrum. We will not focus on the P2S and select on our range only the chlorine 2P. Say around 195 eV for the low energy side and around 203 eV for the high energy side. Next, click on the icon called Peak Fitting located in the Analysis tab, as shown here. Place the peak fitting window on the side so that it does not obstruct with the fitting view. Select the Peak Fit Table tab to see the properties for each peak. As discussed before, the background type that we will select for our peak fitting is the Smart Background. It will fit a Shirley background if the background is higher at the high binding energy side, and it will fit a linear background if the background is higher at the low binding energy side. Now, as discussed before, the chlorine 2P is made of 2 components, namely a doublet. Here we can only see 2 peaks, so only one species can be visible at first. Press the Add Doublet button. 2 peaks are created on the peak fit table, with the 2p1/2 component being constrained to the 2p3/2. Both components have the same width and the same Lg ratio. Next, click onto the Fit Peaks tab. Here the fitting method must be using the convolve fitting model, as the peak shape is a convolution of Lorentzian and Gaussian. For a fit using the convolution method, the width for a standard chlorine 2p doublet is around 1.1 to 1.4 eV on this instrument. The Lorentzian to Gaussian ratio, or Lg ratio, is expected to be 20% for that kind of width. For a width below 1 eV, this Lg ratio can increase to a value between 30% and 60%. The narrower the peaks, the higher is the Lg ratio. Then fit your peaks by clicking on the Fit This Level button. Check the width and the Lg ratio values. The width here is very good, above 1.1 eV, and the Lg ratio is close to 20%. If you are not interested in the chlorine 2P as it may just be a contaminant, you could just stop here. From the knowledge view it seems that this peak is related to metal chloride. Change the name of the 2 cells to Cl2p3 metal chloride and Cl2p1 metal chloride. If you are interested in fitting properly this core level, then you should look more attentively at the fitted data. The first thing you should notice is that the fitting model is not fitting well around 200.5 EV and 197.5 EV. The second thing you should notice is that the CL2P1 component is constrained to the 2P3 component using a factor of 0.54 instead of 0.5. Change this value to 0.5. Re-click on Fit this level. Now we can see that our model does not fit well anymore with the data. This is an indication that there may be another doublet, i.e. another species. Let us add another doublet by clicking on Add Fitted Peak tab and then place the peak to the low binding energy side. This prevents creating a weird type of components that Avantage seems to want to create. Select the 2P3 component and bring it towards 198.5 EV. As explained before, the rule of thumb is that all peaks or doublets have usually the same or similar width and LG ratio. This is done by writing A times 1 in the cells shown. Again, change the height constraint to 0.5 instead of the 0.54 for this new doublet. Then fit this level and wait for the results. Wait a bit longer. The result of the fitting model matches exactly the data. It is now time to understand our data. We have two doublets where the two main peaks are located at 197.8 EV and at 198.8 EV. The knowledge view, shown here, does not give us much information of what the species could be. Let us look at the NIST library. I have made to list the different species to range from low to high binding energy. We will specifically look for copper in the list. The first species in the list matching with the binding energy of the main peak of the first doublet is an organic copper chloride at a binding energy of 197.6 EV. Let us call it C(N) copper chloride. Write in column A bracket C minus C bracket N minus C U C L. Write the same name in column B. The second species in the list matching with the binding energy of the main peak of the second doublet is a copper chloride 2 at a binding energy of 198.7 EV. Let us call it CuCl2. Write CuCl2 in column C. Write the same name in column D. Now accept this fitting. And that is it, you have now fitted chlorine 2P. If you like this course, then please subscribe. Ha 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 ha, I was joking of course.